So, welcome to Chapter 2 of Geometry. Today's 24th. Let's have a look at our learning targets for today and see what we're looking to walk out of here with. So, our learning targets today revolve around three specific angle pairs. You're going to learn about a dozen different angle pairs in this unit, maybe a little less than that. Our focus today is on three. Those angle pairs are complementary angles, supplementary angles, and vertical angles. Can I get you guys to please pause on the side conversations? Thank you. How many of you, just give me a discrete thumbs up, how many of you have heard of complementary angles and supplementary angles? Maybe you don't remember what they are, but you've heard those words before. Usually about half of my students have heard of complementary angles and supplementary angles. I'm going to guess most of you have not heard of vertical angles. That's probably going to be the thing that's new for all of us today. Vertical angles, it's not my favorite term. I kind of wish they'd call it something else because vertical makes me think of up and down, and vertical angles are not always vertical from each other in terms of up and down. So I wish they'd come up with a different name. I'm going to ask you guys for your opinion later on what you think they should have called it. We're going to call them vertical angles. I'm going to show you what it means today. But let's start with complementary and supplementary angles. So if I have two angles, and there's something special about these two angles, then we say these two angles are complementary to each other. Anybody remember what has to be special about two angles to make them complementary? What are you remembering? They have to add up to 90 degrees. That's totally it. So if I got two angles, and this one over here is 40 degrees, and this one over here is 50 degrees, 40 plus 50 is 90. Those are two complementary angles. Okay, so complementary angles are just a special pair of angles that add up to 90 degrees. All right, so there's one of our learning targets already covered, but we'll practice with that here in a minute. And then supplementary angle is very similar to that. It's also, I'm going to have two angles, and they're going to add up to something special, but it's not 90 degrees. What's the other really important angle that we see a lot in the real world? 180. So supplementary angles add up to 180. Complementary add up to 90. Supplementary add up to 180. Vertical angles we'll talk about here in a minute. So let's burn through the first part because I think a lot of us have seen this before. Angle relationships. So I'm going to read through part A here. It says two angles whose measures have a sum of 90 degrees. Underline that. Are called complementary angles. That's one of our learning targets for today, so let's circle that. This says, since angle ABD is a right angle, if you look at this picture, when they say ABD, can you guys now read the letters ABD and know what angle they're talking about in this picture? Is it this small angle, or the big one that contains both? The big one. Okay. So angle ABD is a right angle, and we actually didn't need them to tell us that because they already put the little box there to show us that. Angle ABD is a right angle. That means that angles ABC, this one, and angle CBD, this one, are complementary. All right. They've given us a measure for angle CBD. Can you please write the number 76 in the correct place in this diagram? One of the key things that we're going to be pushing really hard in this unit is when you've got a picture, especially when something shows up in your assignment, if they give you a picture and then they tell you something about the picture over here, we want to put that information into the picture. That's easy to do if you've got a handout. If you don't have a handout and you're doing it out of the online textbook, I'm going to ask you to draw the picture and put the information in. All right, did you all get 76 in the right place? Did you put it here? All right. So they're saying if this is 76, then what would angle ABC measure be? So what I know is that the measure of angle ABC, since it's complementary, it must add up with 76 to equal 90 degrees. And what is that? Is it 24 or is it 14? All right. So I think 14 degrees is our answer. Let's go ahead and put 14 degrees in here. And one of the nice things about geometry is when you're solving problems like this, it's often very simple to check and make sure that your numbers are correct because, like in this case, I could really quickly, mentally or in my calculator, add up 76 plus 14, get 90 degrees, and be very confident that we're doing the right thing here. All right. Out of curiosity, is there something, if these angles were more complicated and had decimals or something like that, what would you do in your calculator to get that answer of 14 degrees? What would you do in your calculator to get it? You could do 90 minus 76. So take the angle you know, subtract it from 90, and that will give you that 14 degrees for that answer also. All right, so those are complementary angles. They add up to 90 degrees, and we knew that because of the box. Now, in this next picture, they give you something called a straight angle. They mention it in the paragraph over here. A straight angle is when you've got a straight line, and a straight angle will always have the same measure. If you think about it, if I draw an arc going around from one arm to the other, it's always going to be a half a circle. And how many degrees are there in half a circle? 180. So the entire big angle here is 180 degrees, which means these two smaller angles, this little angle and this little angle, must be adding up to 180, which means they are supplementary angles. So supplementary angles add up to 180. In the description here, they tell us that angle LMP is 62. Could you please write 62 in the proper place in this picture? Which of those angles is 62? LMP is 62. And then let's see if we can figure out what our other angle is going to be. So I'm thinking in my head, 62 plus whatever that other angle is has to give me 180. Or I might be thinking on my calculator, 180 minus 62 equals something, and we're coming up with 118. 118. So let's write our final answer. The measure of angle PMN is 118 degrees. See ya. All right, complementary, supplementary. For me, I've heard these words enough that I know that one of them adds up to 90 and one of them adds up to 180. The tricky thing for me is not mixing them up. But I've heard some pretty good tricks about how to remember which one goes with which. I'm curious if you guys can add to my bank of mental tricks. Anybody come up with a good mental trick to help remind you that complementary angles add up to 90 degrees and supplementary angles add up to 180 degrees? And not the other way around? You guys have any ideas? No ideas? It's kind of late in the day for a creative request like this. I'll tell you some of the cool ones that I've heard. I had a very artistic student that that drew this cool picture of two angles, and they were hanging out together. And one of them said, what was it? I like your shoes. You get it? They're complementary. Oh, we could even make it. Oh, I just thought about it. We could even make it. Oh, I like that. Two angles eating dinner and having supper together. Oh, that's awesome. Nice. I was going to say, we could add on to this, instead of saying, I like your shoes, we could say, your shoes are really cute. I love the supper thing. Yes. So supplementary angles, they're eating supper. Complementary angles are giving each other compliments. Here's some other ones that I've learned. One person said just go alphabetical order. Which one comes first, complementary or supplementary? Complementary comes first, and what number comes first, 90 or 180? 90 comes first, so C comes before S, 90 comes before 180. I like that one. That one works for me. I really like the supper one. I've never heard that one before. Thank you. Nicely done. All right. That's going to be the biggest challenge, is just remembering which goes with which. All right, it's time for us to get on to our third part of our learning target today, which is vertical angles. And again, I want you guys thinking about what you would call these if you'd been in charge when they decided to make these. So to do this, we're going to start with this problem, these two problems right here, and then I'm going to show you what vertical angles mean. So they've already given us this 23-degree angle. They've asked us to find these other three angles. This, guys, I'm going to tell you, you're going to see problems like this on an upcoming test or a quiz. When you see a problem like this, please do yourself a favor. Fill in the picture first. Get all your numbers into your picture first, and then come back and answer these questions. Okay? Ignore all this right now, and let's just think through and see if we can figure out what all the angles in this picture would be. So could I get you guys to focus, please, on this angle right here? You see where I'm pointing? And can you tell me what's the relationship between this angle and the 23-degree angle? Are they complementary or are they supplementary? They're supplementary, which means they should add up to 180. So where's the 180 come in with the supper? It's the... I'm going to have to think through that. I like this supper supplementary. Okay, someone help me out. What's 180 minus 23? 157, is that right? All right. How do we know that was 157? Because they're supplementary, they've got to add up to 180, and we could do a quick check. If I typed in 157 plus 23 and I got 180, that would make me feel pretty confident. All right, let's do the one on the other side here. What's the relationship between the 23-degree angle and this angle? They're also supplementary, right? Well, this angle didn't change, so this must also be 157. Agreed? Okay, now see if you can find the bottom angle. I'm going to say, let's look at the 157 right here. What's the relationship between this angle and the 157? They're supplementary, which means they also add up to 180, which means it must be 23. These have to add up to 180, right? And then these would also have to add up to 180, and they do. So, all right. So we got lots of supplementary interactions going in here. Shh. All right. Can we use that information to fill out these answers? Get the right numbers in the right places. I'll give you a hint. 2 of them are 157, and 1 of them is 23. Just answer these for me. You got all the information you need on your pictures. AEC is 157, DEB is 157, CEB is 23. Okay. Do you guys have a question? Can I get you to pause for a minute? I don't want you to miss this next part. This is the key part that most of us don't know from our learning target yet. Okay? Vertical angles. So vertical angles are angles that are formed when you have two lines that cross each other. So I've taken away all the other information. We've just got these two lines. Guys, I'm asking for a second time. Please stop. You're being a disruption of the people that are around you. Thank you. Eyes up here. Don't miss this, please. I got two lines that are crossing each other. And when we have two lines that are crossing each other like this, angles that are across from each other are called vertical angles. So this angle that used to be 23, I'm just going to mark it with an arc, and I'm going to put a single arc down here as well. And that is showing me that no matter what this top angle is, this bottom angle is going to have to be the same. Those are called vertical angles. So angle AED and angle CEB would be a pair of vertical angles. And what's special about vertical angles? They equal each other. They're always the same. Okay? Now here's why I don't like the term vertical angles. Can you see why I don't like this term? Because they're not always vertical. There is another pair of vertical angles in this picture, and they are not up and down from each other. The other pair of vertical angles in this picture would be angle AEC and angle DEB. Those are also vertical angles. I feel like when they called it vertical angles, they sort of tricked me into thinking about things that are on top and bottom from each other. But vertical angles can also be side to side or diagonal from each other. The key information is that they're across from each other when two lines cross. So I kind of challenged you at the beginning, or I warned you I was going to challenge you. If you had been in charge when they were writing the textbooks for this stuff way back in the day, what would you have called them instead of vertical angles? Crossing angles, I like that. Intersecting angles, I like that. Crossed angles, that would make more sense, right? Because they're across from each other. I agree. Why they call them vertical angles? I have no idea. There are a few things. There are a few people that I would like to meet that like that made some mathematical terms that I would just like to give them a piece of my mind and be like, that was just not a good idea. The other one you're going to learn about next year in Algebra 2. Have you ever heard of an imaginary number before? Why would somebody take one of the most important concepts in modern mathematics and give it such a ridiculous name? Imaginary numbers get used all the time. If we didn't have imaginary numbers, 3D graphics wouldn't exist, cell phones wouldn't exist. There's so much mathematics that relies on imaginary numbers to work, yet they called it something that makes you think that it's like going to be like elves and unicorns or something like that. So imaginary numbers, vertical angles, whoever came up with these things, I wish that I could go back and give them a piece of my mind. But whatever. We're going to call them vertical angles because that's what everybody else calls them. The key thing is, if I showed you a picture right now of two crossing lines, could you point out a couple vertical angles for me? And do you know what's special about them? What's special about vertical angles? They cross each other, but what do they add up to something, or they equal to each other? They're equal to each other. Vertical angles are always equal, and we can actually see that in our picture here, 157 and 157, 23 and 23. And it doesn't matter what the number is, vertical angles will always be equal to each other. So that's our main learning target for today. However, we are going to practice something else that's going to be really important, and I'm going to warn you before I flip this page that this next thing is going to be the thing that for some of us will be the most challenging thing about Chapter 2. And it's good that we're diving right into it on day 1. And I'm going to give you some major hints that many of you are going to ignore, but I hope that you'll give it a chance with this because it's going to make your life easier if you'll give this a shot, okay? So what I'm talking about now is not the specifics of these. It's the idea of if I get a situation with a complex picture that's got some algebra-looking stuff marked in it, can I write an equation and solve an equation, and then use my answer from solving the equation to come up with the answer to a question about that picture. So we've got 4 examples here, and the instructions specifically tell us to solve an equation for the variable, and then use that to answer the question. Now, a lot of you are probably looking at part A and thinking there's no need for an equation there. I don't even need a calculator. I can tell you what this missing angle is right here. Okay, but please humor me as I take you through a process that is going to be super helpful to you when, not if, but when you find yourself struggling with these, because these problems are going to get a lot more complicated, okay? Can I get everybody's attention up here? Some of you are burning through this, and that's cool. I love it, but this isn't a race, and I don't want you to miss something that's going to be helpful when we got to do something that's way more complicated than this. So first of all, can I get you to go ahead and put an X right here in this spot? I don't know why you missed that. And I'm going to walk you through my process of solving an equation for this. Now, some of you are going to think this is totally unnecessary, but trust me when I tell you we will come to something where this is going to help. When I go to write an equation that has some variables and some numbers, I'm going to not think about this angle as 152, and I'm not going to think about this angle as x. I'm just going to think about them as 2 angles in a special situation. And what is special about these 2 angles? They add up to 180. I love it. Can somebody tell me that key vocabulary term that's part of our learning target today? They're supplementary. They add up to 180. In fact, I think it's a good idea to write that supplementary down. And they add up to 180. So here it is right here, guys. I am going to write an equation that says I have 2 angles adding up to 180. And when I do this, you are always going to see me do this. I am always going to write some blanks for those angles. I'm not going to write 152 plus x equals 180. I'm going to write blank plus blank equals 180. And then I'm going to double check from my picture, Is this equation actually representing what's going on? This shows two angles adding up to 180. Is that what you see in the picture? If the answer is yes, then I will go back and fill in what these two angles are. What I'm doing is I'm giving my brain a chance to do this problem in two separate phases. One where I'm looking at the geometry of the picture. I'm looking at the situation and asking myself, what's special about these two angles? And I'm just thinking about the fact that they add up to 180. Then, once I'm convinced I've got that part right, now I'll go ahead and bring the algebra in so I can deal with it. If you try and mix those two things together, you are going to make mistakes, okay? Some of you who, if you've worked ahead, I bet probably half of you who started Part D down here have already done it wrong, okay? I would be willing to bet that. All right, but let's go ahead and finish this up. Now that I've got this, I can go ahead and solve it. Let's do our algebra steps to get x by itself. Minus 152 on both sides, minus 152. And I'm going to cancel and get x equals 26. How about 28? Yeah, thank you. Now, I'm sure many of you probably would have been able to get that without writing an equation, just looking at the picture. But again, the reason I'm showing you this is I'm trying to teach you a technique that's going to make things easier for you later. By the way, x equals 28 is not the correct answer to this question. If you circled that on a test, you would get most of the points, but not all of them. Did the instructions ask you to find x? No, they asked you to find the measure of angle MNP. And the measure of angle MNP is not 28, it's 28 degrees. That's a full credit answer right there. Now, my most common mistake that I still make with these is I'll solve for x and I'll be super excited that I'm finished with the problem, and then I'll forget to go back and do that part that I just did. All right, so let's go through that process again. So I'm going to give my brain a break, and I'm not going to make it think about the 4x minus 5 and 3x plus 2. I'm just going to let it think about these two angles. And what in this is special about those two angles in this picture? Do they add up to something? Do they add up to 180 or do they add up to 90? No. What do these little tick marks mean here? Oh, that means they're equal. Okay, so this time around, I'm going to write an equation that says two things are equal to each other. So write me an equation that says blank equals blank. And then pause before you fill in those blanks, pause, and ask yourself, does that equation represent this picture? Is this picture truly showing two angles that are exactly the same as each other? Do we know that for sure? Yes, they're marked as equal, so they must be equal. Okay, now go ahead and fill in the algebra part, the 4x minus 5 and the 3x plus 2. And we'll do some algebra steps to solve this. Do we need to move for a couple minutes so that we can finish this up without the distractions, guys? No? Okay. If you feel the need to, you're welcome to do that. Thank you. When you finish solving for x, go ahead and check against mine. And then I want you asking yourself your question, is that the final answer? Is that what they asked us to find? No, that is not what they asked. They asked us to find the measure of angle FGH. Would somebody help us out for anybody who might be wondering, how are we going to do that? FGH is this angle right here, right? What am I going to do to figure out what FGH is? Yeah. Yeah, we got x is 7. I think I did this right. Did you guys get 7 also? So I'm going to plug 7 in for my x value. And I'm going to figure out what this is. 3 times 7 is 21, plus 2 is 23. I think that's my answer. You know what I love about these types of problems? There is usually a really quick and simple way to make sure you did it right. They didn't ask me what this upper angle is, but I'm going to go ahead and find this one too. 4 times 7 is 28, and 28 minus 5 is 23. Why am I feeling really good about that 7 right now? Because I got the same angle on both of these, and didn't we set up the equation to say that these two angles were going to be the same as each other? So I know I didn't make a mistake then. I know it's 7, and I know that the correct angle is 23 degrees. All right, I would like you guys to do the two problems at the bottom of the page. I'm going to put answers up here. I don't know why there are two D's. One of this should be C. I'm going to put our answers up there. Go ahead and check. And while you're working on that, I'm going to circulate around, answer a couple questions, and maybe stamp some assignments. Hey, I gotta just do one quick check and make sure we're all good. Can you all give me a thumbs up if you're good on complementary and supplementary? Complementary angles add up to 90, and supplementary angles add up to 180. Give me a second thumbs up if you're feeling okay about vertical angles. What's special about vertical angles? They're across from each other, but what's special about them? They're equal to each other. Wonderful. That's awesome. All right, you guys nailed it today. Thank you, thank you.